Chapter 3. The last session we had 3 sections. As we went through the last 3 sections of Chapter 2, that's the last time this year we'll combine that many together. In Chapter 3, we do combine a couple sessions. We do this 3 times, but this one that we're doing today, relations and ordered pairs, just this one session. That's because it's got some really fairly new ideas, I think, for you. A Cartesian product, this may be new to you. The elements of a relation, this will be old, you know this. Domain and range, you know that. Set builder notation, you may or may not be familiar with this. And all of this is being done so that you can graph a set in the future. We're going to start with a little review of things that probably will seem pretty familiar. Sarah has 3 pairs of shoes. She's got pair 1, pair 2, and pair 3. She has 2 hats, A and B. Write all possible combinations of shoes and hats. Okay. So we have 2 different ways we can do pair 1. We have 2 different ways we can do pair 2, and 2 different ways we can do pair 3. For each of these, we can combine with the A hat, or we can combine with the B hat. Now I just did that graphically. Suppose I were to write this out with using the 1, 2, 3 and the AB. What would they look like? Well, this one would be 1A, wouldn't it? 1A. And this one would be 2A. And this one would be 3A. And then we'd have 1B, 2B, and 3B. And if I want to write these out in a little bit more formal way, I could do it like this. 2 comma A, 2 comma B. 2 comma A, 3, and 3 comma B. A coin is thrown twice. Write all the possible ordered outcomes, such as, okay, I could first throw a head and then throw another head, or that first head could be followed by a tail, or my first throw might not be a head, it might be a tail, and my second throw a head, or that second throw might be a tail. So how many possibilities do I have here? 4. Ordered outcomes. Relations and ordered pairs. So here's what we came up with for our ordered pairs with the shoes and hats. If we think of this as set A, right here, this is set A, and this is set B. And one of the ways we denote a set is with these curly brackets. Our Cartesian product will combine two sets in a very specific way. A cross B is combining set A and set B in the very way we did it earlier. Notice A is the first one. That's the shoes, which consist of 1, 2, and 3. B is the second member, which consists of only two elements, A and B. Now suppose we were going to write this as B cross A. Then we'd have A and these are of course the lowercase. This would be the first of each of these pairs in this Cartesian product. And then the second piece would be the members of set A. Okay, so this is what we just did. A cross B, and then we looked at B cross A. So the product looks different. What can we say about a Cartesian product? It is not commutative, is it? The position does matter. When the commutative property applies, you can commute from one position to another and it remains the same. Cartesian product, it matters which comes first. Does A cross B equal B cross A? No. Is the Cartesian product commutative? No. If C cross D equals D cross C, if this turns out to be true, what must be true about C and D? That's the only way this could be true. If E has 4 elements and F has 5 elements, how many pairs does E cross F have? Well, we have seen in some previous examples, when we had 3 elements and 2, we got 6 members. 2 and 3 member sets yielded 6. When we had a coin thrown twice and it had 2 possible outcomes, 2 and 2, that yielded how many outcomes altogether? So you probably have arrived at a thought for this one, and if it is that 4 and 5 element sets will yield 20, I agree with you. If H cross G has 12 pairs, okay, and G has 2 elements, how many elements does H have? Yes. We've seen the relationship now, haven't we? We're saying 4 times 5 will give us the number of elements. Find the Cartesian product E cross F, where E is H, T, could be heads and tails, and F is 0, 1. The Cartesian product of E cross F. So H is going to be my first member, or T. And I know I've got 2 possibilities here. We can either have 0 or 1. Now have I captured all the pairs I could get out of this? I have. So this is the Cartesian product, E cross F. Find the Cartesian product F cross E. And we have, it's still defined the same. So now I've got F is my first element, consisting of either a 1 or a 0. And E is my second element, H or T. So I guess it's not difficult, is it? It's just a matter of getting used to the terminology. Set A, set B. Now in this case, look at this. These are identical to one another. In this case, set A is equal to set B. List the set of ordered pairs for which the first member is more than the second member. 1 is not greater than 1. 2 is greater than 1, so this one qualifies. First member is more than the second member. This one, that's true. Not true, not true. This one's true. And then for these, it's not true. So the list of ordered pairs for which the first member is more than the second member is recorded right here. So we just defined a relationship here, didn't we? I'm going to now mark the domain of this relationship. Let's record it. It would be 2 and 3. It's the first members in that relation. So 2 and 3. Now 3 of course occurs twice, but I do not have to mention it twice or list it twice. And for my range, that's the second element, it's 1, 2. So that's the relation that I have here. And the relation that we defined was that the first had to be greater than the second. Let's look at another one. If A has 4 elements and B has 5, what are the minimum and maximum numbers of ordered pairs in a relation from set A to set B? That should be capital. Well, we don't know what that relation is. We also don't even know what the elements are. So I guess we'd have to say that the minimum would be 0. And the maximum, who knows, maybe they all would work with whatever that relation is. And that would be 20. So somewhere between 0 and 20. Home on the range. Well, why did this come to my mind? Because domain, in some language I studied sometime, had something to do with home. And I'm just wanting to drive home. Sorry for the pun. Yeah, drive home that domain is the first element in a relationship, and range is the second. List the domain and range of the following relations. Okay, we've got this relation here, and the domain we know is the first. There it is. So we've got the domain is A, B. And the range is B, C, D. I like to put them in alphabetical order. How about this one? The domain is 1, 2, and the range X, Y, Z, and W. So I would say W, X, Y, Z. Relations and ordered pairs. We're going to use set builder notation here. How do we read this? X such that. We read this as such that. Such that. X is greater than Y. So we'd look for the pairs in which that was true. Use this set, which is just some even numbers, and we're going to find X such that X is less than or equal to 4. So what is that set going to look like? Well, 0 is less than 4, so it's going to include 0. 2 is less than 4. 4 is not less than, but it's equal to, and that's included. 6 and 8 are excluded. So we have now found all X such that X is less than or equal to 4. For number 2, we're going to use R cross R, and R is defined for us right here. So for my first member of the pair, I use R, and for my second member of the pair, I'll use R. So what's that going to look like? Well, I know that that first member is going to be 1 4 times, and then it's going to be 3 4 times, and then it's going to be 5 4 times, and then of course it's going to be 7 4 times. All right, and we'll go to the second member, which I know is also going to happen 4 times for each of those. And that's going to be 1, 3, 5, 7. Oh, I shouldn't have done it that way. Okay. 3, 5, 7. Now I'm going to have to search around. 5, 7, 1. I'm sure you would have done it in a little bit less confusing way. So I've got my, how many pairs here? 4 by 4, 16 pairs. And what I'm interested in doing is finding for which pairs x, y such that y is x plus 2. Or what's another way I could say that? Y is 2 more than x. Well, that's not occurring all that many times here. Let's see where it is occurring. Okay, so y is 2 more than x. It occurs here, here, and here. Strange how I happened to set it up. They lined up. Maybe it wasn't such a bad thing to do after all. So the set of pairs which satisfy this condition that y is equal to x plus 2 can be written as just 3 pairs. Make that into a comma. Sometimes my writing gets a little sloppy here. There. I actually had good handwriting before I started using this.